Okay, last lecture of the third 9 weeks. You guys made it. You're on your 10th lecture. Good for you. I am very proud of you that you're hanging in there. Okay, so last one. This is not difficult stuff. It's a lot like molar mass, just a couple of extra steps. But I want to write this on there just to help you celebrate it. Last lecture. And then you are officially 3/4 of the way through chemistry. So be proud of yourselves. You're getting there. Okay, so percent composition. Obviously, we're working with percentages. And really what we're doing is just breaking down chemical formulas into percents. What percentage of the formula is made up of hydrogen? What percentage of the formula is made up of oxygen? Just things like that. So your EQ number 29, last EQ also, this one right here, last EQ before I come back. What is percent composition and what are the two ways to calculate it? Okay, so that's what we're going to talk about. There might be some pausing during this one because you have some steps to write down. This one will be a little longer than yesterday's, so you kind of have, we'll do this for the whole class period. But then you get a practice sheet tomorrow and you've learned all you will learn. Look, I did them in the right order this time. I don't have to rearrange anything. I learned on the last slide, last PowerPoint ever, that not to stack them. All right, I'm going to give you a second, so go ahead and pause, and then I'll explain this in a minute. Okay, so percent composition. It indicates the percent of each element present in a compound. So this is an example. If we were to break down sodium chloride, it is actually 39.33% sodium and 60.66% chlorine. All right, not, and again, there's always so many times where I say, wouldn't chemistry be so easy if it was like this? And it's not. This is just another one of those times. NaCl is not half sodium and half chlorine. It doesn't work that way, unfortunately. We have to take into account the mass of each one of these. All right, their masses, their molar masses have so much to do with it. So you have to think about it. If you look up sodium, sodium is 22.99, I believe. I could be making that up, but I'm pretty sure I remember it being that. I'm going to roll with that. And chlorine is 35.45, right? They're both grams. So these can't be half and half because they're not the same mass. All right, so that's why these percentages are, they have to be calculated. You can't just estimate them because of their masses. If every element weighed the same, then absolutely it would just be 50-50. But we know they don't. They all have different masses. So that's what we have to take into consideration. Okay, so first way to calculate is by mass. And this is actually the easier way when the actual masses are given. There's a little less math to, actually, no, it's not. They're both easy. I'm not going to say that. One way you're given the masses, the other way you get the masses from the periodic table. They're both very easy. Okay, so this one, I'm going to put these instructions up. I think it's all on there. Yeah. Calculating percent composition by mass. Okay, mass being the key term here. So I'm going to give you a chance to copy this. We'll go through these steps using an example. So pause now. All right, so as it says, and again, reading through these is not going to mean much without an example, but we'll look at them real quick. Step 1, you're going to divide the subtotal for each by the total mass. So it's kind of like calculating your grade. Obviously, if you get 8 out of 10 correct, you do 8 divided by 10 times 100 to get 80, right? That's exactly what we're doing. The subtotal divided by the total, then multiplied by 100, and then just make sure your significant figures match right after the decimal, and that they add up to close to 100. That's what that little symbol down there means, is pretty much 100. They might be off by a little. As long as they're only off by, you know, a couple of decimal places, you'll be fine. So let's go through those steps for this example. Okay, so these aren't even real elements, it's just a very generic example. So it says a sample of a compound contains 55 grams of element X and 75 grams of element Y. Find the percent composition. All right, so the way we do that, so take X, right? To find the percentage of X first, you want to take the mass of X, which we were told was 55, over the total mass, and you're just going to get the total mass by adding the two together. Right, 55 plus 75, you get 130. Notice none of these have decimal places. Yours doesn't have decimal places either. And actually, yeah, we'll just stick with that. So, mass of your element divided by the total mass times 100, you get 42% of element X. Do the same thing with Y. Y is 75 grams. Do 75 divided by the total times 100, you get 58%. I know a lot of you will want to, and I'm not telling you not to, a lot of you will want to just take kind of the easy route, and once you calculate 42, if you realize, oh, well, I can just do 100 minus 42 and get 58 to calculate this number instead of doing the math, that's fine. I'm not going to tell you that you can't do it, but here's the problem you'll run into, is if for any reason you did this math wrong, then it makes both answers wrong, right? Because if all you're doing is subtracting, you're going to get the wrong answer because the first number was wrong. My suggestion is to do the math for both and then check to make sure they add up to 100. So then you can check, well, I've got 42 and 58. If I add those up, they give me 100%, then I'm good. This is the way I prefer because it's a little bit of a way for you to check to make sure you're doing the problem right. If you do it this way, if you make a mistake on the first one, both are going to be wrong. So your call, not mine. I'm not going to tell you how to live your life. But just my suggestion, the best I can give you. Okay? I'm going to put up the steps for the second one. We'll go through that, and then we'll do one more example of each, and that should be it. All right, but you guys might need some time. This one's got a lot of writing on it. All right, so pause for as long as you need to. You have time. This won't be a super long lecture, and you have all class periods. So just notice the keywords in this are chemical formula. So in this one, you'll be given the chemical formula first. So go ahead and pause now. Okay. So if you're given the chemical formula, that's like saying, you know, I give you H3PO4 and I want you to calculate the molar mass just using, calculate percent composition just being given that. Right? That's what these instructions are for. So your first step, calculate the molar mass. After that, it's pretty much the same idea as as calculating by mass. You want to put the mass of the element over the total mass or the molar mass, and then divide by 100. Okay, so I have it written out as a almost like an equation down here. So to find the percent composition, mass of element divided by mass of compound times 100. Follow significant figures and then make sure it adds up to 100. Okay, so the only real difference is you have to calculate molar mass and your subtotals first. Okay, you're not being given those as numbers already. But we know calculating molar mass is not that difficult. So this shouldn't be super challenging. All right, so next example, I'm going to cover the answer for now, is it says calculate percent composition of water, of H2O. Okay, so if you look back at step one says calculate the molar mass, right? So if we're going to do that, we know that we have 2 hydrogen, right? So 2 hydrogen, and the mass of each hydrogen is 1.01. Let me zoom in on that a little. Move over. Okay. So 2 times 1.01, you get 2.02, right? And that is, grams of hydrogen. Oxygen, we know we only have one, and that is 16. So 1 times 16, we know it's just 16.00 grams of oxygen. Step 1, oh, sorry, and then obviously we're calculating the whole molar mass. So add those up, you get 18.02 grams of H2O. All right, so that's your math for step 1. All we did was calculate molar mass, something you, I'm sure, did a lot of yesterday. All right, so now we have, look, you did everything you needed to do mathematically for the rest of the problem in this one. You have your mass of your hydrogens, the mass of your oxygen, and the total mass of your compound. These are the numbers you're going to work with next, okay? So step 2, if you look back at step 2, divide the subtotal by each, the subtotal for each element by the molar mass, and then multiply by 100. 2 and 3 kind of go together, okay? So we're going to do both of those at the same time. So let me switch these so I can cover the answers. All right, so as it says, steps 2, 3, and I guess really 4, because significant figures aren't really that difficult. So we know if we're going to do hydrogen first, okay, the percent of hydrogen first, we have 2 hydrogen, right? So that's why we use the mass 2.02. Do not use 1.01 because that's the molar mass of hydrogen. You have to use the number that you have. Okay, we have 2 hydrogens, so not 1.01, 2.02. So 2.02 divided by the total molar mass, which was 18.02, times 100. Get your answer, okay? Notice we have 2 past the decimal, 2 past the decimal, keep 2 past the decimal. So you get 11.21% hydrogen, which makes sense because think of how small hydrogen is compared to how large oxygen is. Right, hydrogen, they're each only 1.01 grams compared to the oxygen that's 16 grams. So this should be a very small percentage because they don't carry a lot of mass with them. Okay? Think of it as like if you have a whole bunch of change, you know that even if you have, I don't know, 50 pennies, right? You have a lot of them, but they're only worth 1 cent a piece. 50 pennies is this, you know what I mean, is the same as 2 quarters. Okay, so the smaller mass is just going to make up, you know, a smaller amount of your percentage. Next one, you're doing the percent of oxygen. We only have 1 oxygen, so it's 16 divided by 18.02 times 100. You do that math, you get 88.79% oxygen. All right, keeping the 2 past the decimal place. All right, so for hydrogen, 2.02 divided by 18.02 times 100 gives you 11.21% hydrogen. 16 divided by 18.02 times 100 gives you 88.79% oxygen. So you have your percent composition. The last thing you need to do, which is what step 5 says, is just check to make sure. Hopefully in your mind you're already adding those up to make sure. But if you add 11.21 plus 88.79, you get 100% exactly. Doesn't always have to be exact as long as you get something like, you know, 99.98, you know, something like that. Or even if you get something like 100.02, those are fine as well. If you get 102 or 98, you've done something wrong. Okay, those are not acceptable. Off by a couple of decimal places is fine. Okay, it just depends on what periodic table you're using and if you have to round your numbers or not. All right, so not a lot more, actually not any more difficult, just a few more steps. All right, so let's do our last 2 examples. Let's zoom out. Okay. So I'm going to give you a chance to pause, write these examples out. If you want to work on them and try them, you're more than welcome to. But I will work through both of them, so go ahead and pause now. Okay. You've had time to write them down. Maybe you started working through them. Maybe you're already done with them. I don't know. But we're going to go ahead and work out both of them. So first one, you complete a reaction involving nitrogen and oxygen. If you had 28 grams of nitrogen and 80 grams of oxygen, what is the percent of nitrogen and the percent of oxygen? So just what is percent composition? So is this by grams or by by mass or by chemical formula? This is clearly by mass, right? You're given the mass of each one. You do not need, okay, and I'm going to write this in big red letters for this one. Do not use the periodic table of elements. You don't need it for this one. You're given the numbers, you don't need the mass from the periodic table. Don't look anything up. Okay, you don't need it. You have everything you need right here. Okay, so let's go ahead and do this. So we've got 28 grams of nitrogen and 80 grams of oxygen. Nothing after the decimal in either one, so that just means we're going to stick to nothing after the decimal. So what do we need to do with these two numbers first before we can do any other math? Hopefully you're saying we need to add them up, right, to get a total. So add them, you get 108 grams, okay, and that's your total. You don't know what formula this is because it doesn't tell you, so that's just your total mass. You don't know if this is nitrogen monoxide, nitrogen dioxide. We're going to do that when you come back from spring break. We're going to talk about how to figure out the formula, but you don't know that right now, so you just know this is your total mass. Okay, so you've got mass of nitrogen, mass of oxygen, total mass. You have all the numbers you need. So to find percent nitrogen, let me go ahead and zoom in. Yeah, that should be good. So to find percent of nitrogen, remember it's mass of element over total mass times 100. So the mass of our element is 28. What's our total mass? 108, right? So multiply it by 100. Just looking at your numbers, you should be able to see already that nitrogen is going to have a smaller percentage than oxygen, right? Because it's a smaller amount of your total. So if we do 28 divided by 108 times 100, sorry, I'm getting my calculator out. 28 divided by 108 times 100. Remember, don't keep any past the decimal. So this is what my calculator is telling me. But I can't keep any numbers after the decimal, so I have to round it to the nearest whole number. So what would that round to? Hopefully you are saying 26% nitrogen. All right. Next one, percent oxygen. Do the same thing. It's 80 grams of oxygen divided by 108 grams total times 100. So if we do that math, 80 divided by 108 times 100. This is what my calculator tells me. So you can't keep any past, what would we round that to? You can't keep any past the decimal. Just 74%, right? So 74% oxygen. Last step, check them. Do those add up to 100%, 26 and 74? Yes, they do. You are good to go. All right. Not difficult in the least little bit. Next one says to calculate the percent composition of sucrose. And it's telling you, I'm going to write this on a different sheet of paper so I have room, that sucrose is C12H22O11. Big numbers, but it's not really going to cause a problem, I don't think. All right, so that's our formula. Notice you weren't given masses. So this is where the only place that you are going to get numbers from is the periodic table. Okay, this is where molar mass is necessary. Okay, so let's go ahead and start. You know you've got how many carbon? You got 12. Good. How many hydrogen? 22. And how many oxygen? 11. So we need to calculate molar mass and subtotals for each one of these. So just find molar mass the way we have been. What am I going to multiply those 12 carbon by? What's carbon's molar mass? Good. 12.01. Maybe you have that one memorized. Actually, you should probably have all these memorized pretty soon. Hydrogen, 1.01. And oxygen, 16.00. All of these are 1 past the decimal, so that's how all of your numbers should be in the end, is 1 past the decimal. And you'll be good. So 12 times 12.01, I believe is 30, no, I'm not even going to make myself sound stupid. You all know I can't math in my head, so I'm just going to calculate it real quick. 144.12. I should have known that. Really should have, but it's okay. 144.12 grams of oxygen. Right? 22 times 1.01, that one I can do in my head. It's 22.22 grams of hydrogen. I'm just checking it. Yeah, I'm right there. And then 11, this is not 110, right? It's 11 oxygen. 11 times 16. You get 176.00 grams of oxygen. Oops. Hopefully you all caught my mistake. That's carbon, not oxygen. I'm not there to hear you yelling at me that I made a mistake. But I caught it myself, so hopefully you're proud of me. Oh, sorry. I'm a little tired. If you care to know, this moment in time when this is being recorded is the last day of school. So you all have already taken all of your exams. You are enjoying the first few hours of Christmas break. It is 4:15 on the last day of school. I don't know what you all are doing. I'm spending my first few hours teaching all of you. So it shows you how much I love you. Some of you. Not all of you. Sorry. Next thing we need to do is add all of these up. So 144.12 plus 22.22 plus 176.00. You get a total mass of 342.34 grams, right? And that's of sucrose, of C12H22O11. All right, all your numbers are here. Notice we're not done yet. All we did was calculate molar mass. We now need to calculate the percent composition of each one of these. All right, so for carbon, hydrogen, and oxygen, let's do carbons first. So we want the mass of carbon, all of the carbon, not just one of them, all of them. And I'm actually not going to put the grams just to save space. So 144.12 divided by the total, which is what we just calculated down here. So 342.34, and we're going to multiply that by 100. All right, and I'm actually going to set the rest of these up so we can just do all the math at one time. So for hydrogen, it's 22.22 divided by your total, 342.34 times 100, and oxygen, 176.00 divided by 342.34 times 100. All right, those are your 3 math setups. And let's do some calculating. All right. Okay. So first one, 144.12 divided by 342.34 times 100. Notice in all of these we can keep 2 past the decimal. Okay, so for my first one, this is what my calculator tells me. So what would we round that to if we're rounding to 2 past the decimal? Well, notice the 8 is where we're going to round, right? The 8 rounds the 9 up to 10. So this would have to be 42.10% carbon. 42.10% carbon is the first part of our answer. Next one, 22.22 divided by 342.34 times 100. A pretty small amount, right? When you compare these, you have 144, 22, and 176. This is clearly going to be a very small amount because it's not making up much. This is what my phone tells me. 6.4906 blah 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 blah. Round that to 2 decimal places, what do we get? Well, just looking at the 0 to round, 0 doesn't do anything, right, to round up the 9, so it stays 6.49% hydrogen. And then the last one, 176 divided by 342.34 times 100. And I get 51.4108 blah blah blah. So what would we round that one to? It would be 51.41. 51.41% oxygen. So these would actually be your answers. Okay, that's the answer to your problem. Last thing you just need to do is check it to see if it adds up to 100 or at least close to it. So you got 42.10, 6.49, 51.41. Add them up, see if they add up to 100. So you've got 0, 9, and 1 is 10. 8, 4 and 4 is 8, plus 1 and 1 is 10. Looks like we're doing well so far, right? You got 6, 7, 8, 9, 10. And then 9 and 10. That adds up perfectly to... Sorry, you couldn't see any of that. I should look up at the camera more often. But again, add them up. 0, 9, 1, 10, carry your 1. 4, 5, 6, 7, 8, 9, 10, carry your 1. 7, 8, 9, 10, put your 0, carry the 1, and then 9 and 10. So 100% exactly. That means our answers are 100% correct. And we are good to go. So congratulations on listening to your very last lecture. Hopefully this took up enough time. If it didn't, then you guys can just kind of take a breather for a little bit. You can relax a little bit. Tomorrow you get a worksheet on percent composition. You have a quiz next week. And then you get your study guide for your last test before I come back, all right? Remember the test, it's not next week, it's the following week. You can't work with anybody, so keep that in mind. Study, study, study for that test. You've got a lot on that test. You've got types of reactions, predicting the product, and then molar mass and this. All right, predicting the product is by far going to be the most difficult part of that test. So study that chart, okay? Please make sure you are studying that chart. And you should be okay. If you have any questions, make sure you get help. You can go see Mr. Fierro. If you need to, maybe Mr. Perkins can help you. Google, YouTube, do anything you have to make sure you understand these concepts. And I think that's it. I would give you one last look at Dorothy, but she's gone. I don't know where she went. That's it. I miss you guys. I will see you in a couple of weeks, maybe a little before then if I happen to pop in. I have no idea what state I am currently in at your time. Right now I'm fine because, you know, school just ended and Jameson is still part of me, but soon enough he will be here. So I will do my best to come and see you guys, at least to, you know, help calculate grades and do grade tracking sheets and all that fun stuff. So I may or may not see you in a couple of weeks. Hopefully I do. I miss you all and have a fantastic day.